Let's understand what do you mean by uniform and non-uniform motion. Uniform motion. Let us take an example of an object traveling 5 meters every second. That is, the first second it travels 5 meters, the second it travels 10 meters, the third second it travels 15 meters, the fourth second it travels 20 meters, and so on. Now let us visualize this using a graph. Let us consider a distance versus time graph where time comes in the x-axis and distance comes in the y-axis. Now let us try to plot these values in the graph. For the first second, we know that the distance traveled is 5 meters. For the second, the distance traveled will be 10 meters. The third second, the distance traveled will be 15 meters. And the fourth second, the distance traveled is 20 meters. Now, let us join these points to get a line and see what is the pattern that we get. From the graph, we can see that when we join all the points, we get a straight line. This is called a linear graph. We can define uniform motion when an object travels equal amount of distance in equal amount of time. Whenever it travels like that, the graph that you get will be a straight line. This graph is called a linear graph and the motion is called a uniform motion. Therefore, always a uniform motion gives a linear graph. Now, since we have seen what is uniform motion, we can easily define what is a non-uniform motion. Yes, non-uniform motion is when an object travels unequal amount of distance in equal amount of time. Okay, let us visualize non-uniform motion using a graph. We saw that uniform motion had a graph which was linear. Then how will be a non-uniform graph? Yes, it will be anything except a straight line. It can be a line like this or it can be a curve like this. So, anything except a straight line will give you a non-uniform motion when you plot a graph against distance versus time. Activity. Let us try to do the activity given. In the activity section, they have given a table of the distance traveled by object A and object B in equal intervals of time. Let us see, are these in uniform or non-uniform motion? Let us take the first example of object A. We can see here that the A travels 10 kilometers first, then 20 kilometers first, then 30 kilometers first, and then so on. Therefore, in each interval of time, its distance increases by 10 meters. Or you can say that in each interval of time, the distance increases by equal amount. We have seen this case, right? When an object travels equal amount of distance in equal interval of time, then we call that as a uniform motion, right? So, object A travels in a uniform motion. In case of object A, we get a graph plotted between time and distance as a straight line, isn't it? Now we'll see for object B. For object B, first it travels 12 kilometers, then it travels 19 kilometers, then it travels 23 kilometers. See the difference between these distances. The first two readings have a difference of around 7 meters. The second and the third reading have a difference of around 4 meters. Here itself we can see that they do not travel equal amount of distance in equal interval of time. Therefore, object B is undergoing a non-uniform motion, and when you try to plot a graph between distance and time, you get a non-linear line like this. Therefore, from the activity, we can say that object A travels with a uniform motion and object B travels in a non-uniform motion.